Hi, in this video, I'd like to discuss the binary search, which is a different type of search as compared to the linear search. It's a much faster search, but it does require the array to be sorted. And we'll go through the reasons why. Alright, so what I'll do is I'll access our course textbook and we'll go to page 33. Let's have a look. 33. Should be about 33. 33, yeah. So 33 here is the binary binary search. Okay, so this is the binaries. This is the code for the binary search. Now, I do want you to try and program this yourself before you really read into it, but this is pretty much a pseudocode for it. But actually, I'll just explain to you roughly how it works. So a binary search will start by examining the middle item. So if you were to look at an array, zero, 1, 2, 3, 4, 5, 6, and get items in there, and I'll make sure it's in order. So I'll start at, say, 10, 20, 23, 25, 30, 40, 60, 100. Right, so make sure it's in order. There's reasons why. It's pretty much obvious when I show you the algorithm why this has to be in order. So this is the index. This is actually what's inside it. And the way the binary search works is it calculates the middle. So it grabs a 0, grabs a 6, adds it together, divides 2, and it gets the value 3. Now if that's a 7, you'll round down to 3. And then you'll look at 3. So let's say you're looking for the number 23. Right, you're looking for the target value is 23. I want to know if 23 is in this array. So the binary search works by calculating the middle and then doing a comparison. So it checks, is 23 less than 25? Or you could check if 23 is greater than 25. So either way, you can check for a less than or greater than. So if 23 less than 25, yes. If it's less than 25, it knows. It knows that 23 must live this half of the array and not this half of the array. So straight away, we call it binary because it's not the top half, but the bottom half. So we've just divided this whole search by 2 in one check. And that's the beauty of the binary search. So all of these things we don't even care about. So the way the binary search works is there's some, so you got 2 counters because you got to track where you're at. So let's chuck in 2 counters. Say this one here, and let's add in another one. We'll change it to color to blue, and this is, we can call this the high counter and the low counter, so, or the high index and the low index. All right, so high and low is added together, divided by 2, you get a middle index. Let's do it. Let's give it another color. We use this as the middle index. The middle index can be a different color. Let's make it black. All right, so middle is here. Okay, so straight away it knows that, oh, it's less than this number. Right? So you'll move this counter down past the middle, right down to this one, and recalculate the middle again. Recalculate the middle. And then the middle goes here. So now it checks. Is 23 less than 20? No. So therefore it must live on this top and not this bottom. So then this counter then moves up. and the middle is calculated again. Now, there's slight variations to the binary search. So if you look here, actually, if you look at the code here, you notice here, you find the mid by averaging the low and high counters, and then you check if the target exists. If it, you check whether it's less than or greater than the target, and then you'll go down below mid -1. All right. If if this is true, then it will be this one should go over here because it's mid +1. So actually, whatever mid is +1, it'll be here. All right. Now the middle is calculated on 2 plus 2 divided by 2 is 2. So the new mid is actually here. So actually, just to reiterate, if it's in the bottom half, this top one moves down past this, goes here, right? However, if it is in the top half, let's say it's this half and not this half, it moves past this mid and goes here. And then when this, and then it does a final check. Is 23 less than 23? No. No. So because there's nowhere else to go, you'll then do another check. Is 23 equal to 23? Now let's just check the pseudocode. Over here, if target equals to that, then it's true. So it does do an equal check first. So it does check if it's equal first, and then check whether it's less than. And this is how this variation works. All right. So that's how it works. Now let's set up the binary search so that we can play around with it. So we can set up this particular array here. I've got two buttons in here. I've got the linear search that we've programmed before in the previous topic. I'll just set that as a startup project. And I've got the binary search here, which I should call btn binary. Binary search. So what I will do is we'll set up an array just so that we can have something to search in. So we'll set an array. We'll call it array. We'll give it 7 locations. Index is 6, and we'll store integers in it. And what I'll do is I'll just store the values that I was using before. Actually, quicker way. Alright, so that's our array. Now let's implement a linear search. Our binary search. So the way we would start off is, I can just start you off a little bit. What we want to do is we want to do a check. So we needed to calculate the mid. Dim mid equals to, we need to set our lows and highs. So the low, dim low should equal to the first location of the array, which is 0. It's always 0. And dim high should be the last index. So array dot length -1. Because the length would be 7 here. 1, 2, 3, 4, 5, 6, 7. But this is number 6, so I got a -1. Then I calculate my middle. And then I check. First I'll do a check if, oh yeah, I need a target. So let's have a target. Our target value is 23. And you can change that. So I check if target is equal to the array inside the location mid, then we found it. So I need another thing to say is found. Right now is found is false because I haven't found it. But if this is true, then is found equals true. Alright. Else, if this is not equal, then we need to check whether target is less than whatever's in this array, then we do something. So we need to move the top counter, high counter. If it's less than, if that's true, we need to move that down past the mid, below the mid. And I'll let you do that part. Else, the last else would be if target was greater than array mid, and then we'll do something else. And you'll need to put this in a for loop because you got to repeat this, a few times. Anyway, I'll start you off with the binary search. See if you can complete it and test it. I suggest after you've tested it, you extend this further to see if it worked and try to do a search for a few others. Anyway, thanks for listening.